Okay, today we're going to talk about naming ions. The most important, or one important thing to kind of get over is this idea of what's a cation, what's an anion. Cations are positive, anions are negative. So if we lose an electron, we become a cation. If we gain an electron, we become an anion, right? Sometimes I hear this confusion. We think gain an electron, gaining is a positive, therefore it must become a cation. This is a really common mistake that I see. So just remember, electrons are negative particles. If you gain a negative particle, it's going to be negative. If you lose a negative particle, you're going to be positive. Cation, anion. One way to remember is the cat, is the T in the cat looks like a plus, so it's positive. Anion, I don't know why you put that in negative. The other way I remember it sometimes is cats are good, they're positive, right? But if you're a dog person, don't use that one. So what's happening is the sodium chloride that we're talking about in the last video, this has this one extra electron here. This has 7 electrons here. In order to get a full outer shell, it has to lose this 1 electron, so that now you have 2, 8. And therefore it has an overall charge of +1. That electron would go over here to chlorine, which means it'll be 2, 8, 8. Right, which is the next one, and therefore has an overall of -1. If we want an ionic compound, it has to be stable, right? And therefore we need an equal number of charges. We can't. It has so overall this has to equal 0. So if we have 1 sodium, well, 1 times +1 and 1 chlorine -1, they're even. So overall, 1 sodium and 1 chlorine is going to balance out, right? You have 1 plus and 1 minus, so you reach back to 0. But that's not always the case. For example, in magnesium chloride, magnesium has 2 valence electrons and can give 1 to one chlorine and 1 to another chlorine, right? So therefore, it has an overall charge of +2. The magnesium cation has an overall charge of +2. The chlorine anion has an overall charge of -1. So if we want the overall charge for the entire molecule to be 0, we're going to need 2 -1s to equal to even out the single +2, and that's exactly what we have. We have MgCl2, remembering that this subscript 2, this little 2 down here, means that there's 2 chlorines, right? And that's represented kind of by this diagram here, 1 Mg and 2 Cls, right? And we can see you can do it mathematically, right? So we can, if we just had 1 Mg2 plus and 1 Cl minus, would end up with an overall charge +1. We don't want that, so we're going to have to make it 2 times the -1 to equal the 0. So the formula has to be MgCl2. Now, for most people, this is not an easy way, but I want to show you because some people this really appeals to them. It gives you a good understanding of what you're actually doing. There is another way though, and I'm going to show it to you now. First and most importantly, you have to be able to figure out the charges on each individual atom or each individual ion. So here's a quick rule of thumb that will work very well in year 10 chemistry. In group 1, we've always got 1 valence electron, don't we? Because that's what group 1 means. So in group 1, we always have 1 valence electron. So if we lose that electron, we're going to always end up with a +1 charge. In group 2, we always have 2 valence electrons. So we lose those valence electrons, we lose a negative, we get +2. Group 13, the new way of marking it, +3. Group 14, it's either +4 or -4 for carbon or silicon, but generally +4 for below that. -3, -2, -1. Now there is some confusion going on here, but remember, we don't want you to look at transition metals and these ones down here. We're not going to worry too much about what they are. in Year 10 chemistry. So you can just remember group 1 plus 1, group 2 plus 2, group 13 plus 3, group 14 plus 4 or minus 4, group 15 minus 3, group 16 minus 2, group 17 minus 1. Using this method, we should be able to identify all monatomic ions within the range that we're going to talk about, right? What's the charge of a phosphorus ion? Oh, it's -3. What's the charge of a beryllium ion? Oh, it's +2 because it's in the second group, right? Polyatomic ions, unfortunately, have no such easy rule. You're just going to have to remember them. Hopefully, I have already given you, or I will give you, a Quizlet full of these polyatomic ions, and you can go away and happily memorize them, because that's the only way you're going to know them, is to memorize them. Usually, we give you an ion sheet on all tests, and we certainly will do that, but going back and referring to the ion sheet and moving forward makes you slower on the test, and that means people who have memorized them are faster and therefore have more time to work on the difficult questions. So I suggest you memorize these polyatomic ions, but they will be given to you. So if once you are actually given these ions, or you know the charges, figuring out the formula can be easily done using something called the cross rule. So if you are asked what's the formula for magnesium bromide, well, we can figure out that magnesium is 2+ because it's in the group 2. We would have the periodic table. We could find out it's in group 2, so we know it's 2+. Bromine we know is in group 17, so therefore it's -1. Yeah, because remember from 17, 16, 15, it works from -1, -2, -3. And then we're going to use something called the cross rule. What the cross rule involves is we take this number here without the plus and we place it down here. Take this -1 or this 1 without the minus and place it down there. So the 2 appears here and the 1 appears here. Now if there's 1, we don't write anything. We're going to assume if you've written this down, there's one of them, right? We don't assume there's 0 of them. I mean, there's 0 uraniums in, magnesium bromide. We're not going to write 0 uraniums, right? We just write what's there. So if there's a 1, you won't bother writing a 1. Right, let's have a look at this again. Aluminium we know is in group 13, so it's a 3. Oxygen we know is a -2, so that 2 goes here. Now we have Al2, and we have the 3 comes down here, so we have O3. Al2, O3. Now the only tricky bit would be is if it ended up, 2 and 2. So if it was magnesium oxide, magnesium is Mg2+, oxygen is O2-, you wouldn't write Mg2O2, right? We want to find the lowest common denominator, so 2 cancels out, make 1, so just to be MgO. This is a tricky thing. We're going to do a lot of practice. Watch this video again to figure it out. But you need to be able to write the formula for ionic compounds. Good luck. Answer the questions below, and I'll see you in class.